For us to hear sound, it does things complex and incredible, but not unknowable. The brain takes sound waves, which journey through the air and through our skulls, and transforms them into sound in our minds. This sonic odyssey is beautiful, filled with weird landscapes, unexpected encounters, catastrophe, and joyful destinations, all like a strange oral fairy tale. Hearing evolved because it helped animals to survive. Hearing allowed predators to find prey and eat them, and hearing allowed prey to spy on predators and to escape. The floppy piece of skin attached to the sides of our head is our outer ear, or pinna. It collects sounds from a wide area of our environment like a reflector disc of a satellite dish. In humans, the pinna is in a fixed position, but in many animals, the pinna are highly flexible and can be oriented toward a source of sound. Curiously, our auditory system has evolved beyond its strict utility of survival. For example, music, through its perception as sound by our auditory system, evokes sensations and emotions. Sound is produced when something vibrates, causing variations in air pressure. Particles of air collide with other particles, and the wave of movement, bouncing from particle to particle, passes outward through the air. This is called a sound wave. And now our brave sound waves are approaching the outer ear and are truly starting their journey. Once they've entered the ear through the pinna, they pass down the air-filled auditory canal before hitting the eardrum. As the sound waves strike the eardrum, the vibrations in the air are transferred through that membrane into a series of little bones called the ossicles. There are 3 bones in this group: the malleus, incus, and stapes, also known as the hammer, anvil, and stirrup. They function to transmit sounds from the air-filled outer ear into the fluid-filled inner ear by allowing the sound to enter them through the eardrum, vibrate through them, and then exit into the inner ear via a second membrane called the oval window. The inner ear contains the sensory organs for both hearing as well as for our sense of balance. The cochlea, an important organ for the auditory process, is snail-shaped, and if rolled up, is only about the size of a pea. Inside the cochlea is the organ of Corti, which sits on the basilar membrane and below the tectorial membrane. And inside the organ of Corti are thousands of auditory hair cells. These hair cells are, in fact, receptor neurons called stereocilia. These hair cells convert the motion energy of sound waves into electrical signals that are communicated to the auditory nerve. From there, the signal goes into structures deeper in the brain until at last it reaches the auditory cortex, where we consciously experience sound. To back up, when our sound waves enter the fluid-filled inner ear, they are thrust into a storm of vibrations that they are in fact creating. The basilar membrane below them is violently shaking and tossing them. The tectorial membrane above them is moving back and forth and pushing and threatening. And in the midst of this maelstrom, as they are broken apart, they spiral through the inner ear, and the sound waves finally begin to weaken. The inner ear absorbs all their kinetic strength, and the sound waves begin to realize that this will be their end. Now, finally, in the chaos of the inner ear, they disappear. But though the vibrations are now no more, they are not completely gone. They have metamorphosed into something new, into neural activity. and they come to life again in the cortex of the brain. In the consciousness of our minds. Their journey is over. The brain has taken what was outside and made it inside.